Hi to everyone. This is M. Sundaran, working as assistant professor in the Department of Agricultural Engineering in Komunadu College of Engineering and Technology. To the course of groundwater and well engineering, today's topic is about the geophysical technical for groundwater exploitation. What is meant by hydrology? Hydro means water, geology means study about the earth crust. Therefore, the hydrology is the area of geology that deals with the distribution and momentum of groundwater in the soil and the rocks of the earth crust. It's called hydrology. What groundwater balance? It's water balance. The law of water balance states that the inflow of any water system, it area is equal to that outflows, which plus change in the storage during the time interval. So that in water balance in inflows and outflows is be equal plus change in outflow during storage time interval. It's called water balance equation. So groundwater balance equation state that general I minus O, so inflow minus outflow is equal to water change in water volume at that time. Considering various inflows and outflows components, the groundwater balance equation the time period given us. For example, some example for various inflows like recharge from rainfall or recharge from canal recharge or if field irrigation or recharge from tank. These are called inflows. Various outflows are like evapotranspiration, draft from groundwater or effluent of region to rivers, outflow to other basins. These are outflows. Yeah, the time of change in groundwater is called W. There are different types of geological formations. First is called aquifer. What do you mean aquifer? Aquifers are types of geological formation, both porous and permeable. Hence, a sufficient discharge can be obtained through them. This porous and permeable, so often sufficient discharge can be obtained. Example: fine and coarse silt. Aquitort. Next, aquitort means the type of geological formation. The porous less permeable. Therefore, water flow doesn't flow through them, but instead it steeps. Example: sandy clay. Next one, aquicular. This is a type of geological formation, high porous but impermeable, highly porous but impermeable. Therefore, the water cannot extract through the geological formation. Example, clay. Aquifer means the types of geological formation that is neither porous or not permeable. It's called graphite rocks. Therefore, section about the groundwater exploration techniques. There are two types: for surface investigation of groundwater and subsurface. Surface means over the surface and subsurface means under the surface of the soil. For such a subsurface surface investigation, we use using remote sensing or geophysical exploration. Geophysical different types. There is electrical resistivity method, seismic refraction method, gravity method, magnetic method. For subsurface, we are seeing geophysical logging, resistivity logging, spontaneous potential logging, radiation logging, temperature logging, caliper logging, acoustic logging. Different methods for groundwater exploitation. First, see about that surface. Surface testing is geophysical. Geophysical techniques like investigations of used for the groundwater, delinting the underground structure, accounts on the disturbance and momentum of the groundwater. It is called geophysical technique. First one, electrical resistivity method. What do you mean by electrical resistivity? Based on the different materials of different electrical residues. By measuring the resistance of subsurface to the electrical current flow, one can interfere with the natural composition and materials present. Therefore, in the diagram you can see that the current meter and voltmeter power supply in the circuit. When there is a change in flow, it affects that. Based on that current flow and exponential flow, you can see that in a diagram. Next one, seismic interaction method. Seismic waves are generated at the surface and direct generated on the surface and enter into the ground, directed to the ground. These waves travel through the subsurface and refracted and bent as an interface between layers with different seismic velocities by measuring the travel times of the reflected waves at various effect possible to infer the depth and velocity of subsurface layers. This is called as seismic refraction method. Next, gravity method. Gravity method means the gravity survey measures the variations in the gravitational acceleration causes a difference in subsurface density. The groundwater being less than dense than rock or solid causes decrease in gravity areas where it is present. Therefore, the gravity of anomalies can indicate the presence of subsurface features such as aquifers. Next one, magnetic method. Therefore, magnetic method means the earth's subsurface materials having varying magnetic properties. Therefore, the magnetic method measures the variations in the earth magnetic field caused by difference in the magnetic substitutability of rocks or minerals. In certain geological systems like faults or magnetic minerals can affect the magnetic field. Their variation can be detected and analyzed. Is using geophysical method. Next, subsurface method. For subsurface, we use borehole geophysics using the groundwater to obtain the information about the lithology, fractures, permeability, and porosity, and water quality as declining subsurface of disposition to aquifers. Borehole geological logging. First, there are four types. First, on the gamma ray logging, electric residue logging, sonic logging, or caliper logging. First, gamma ray logging means measures of the natural gamma radiation emitted by the subsurface formation. Different rock types emits varying level of gamma radiation, helping to identify the lithology. Therefore, the next one is the electrical resistivity method. Provide the information about the resistivity of the subsurface materials. Variation resistivity can indicate the change in lithology, presence of permeable zones. Therefore, the permeable zones here means there is some water getting present. Then acoustic or sonic logging measures the time travel of sound waves through the subsurface, determine the rock density and porosity of the formations. Next, caliper logging measures the diameter of the borehole, identifying the variation in the borehole size, which can indicate the presence of fractures or unstable formation. These are the types of methods for using identifying the subsurface surface and subsurface geophysical techniques. Thank you.